In our paper, we consider the problem of performing marginal inference in distributions over finite sets. For example, consider this set of 9 items, which we will call the ground set. The probability distributions we are interested in assign to each subset of the ground set, like this blue set containing 3 items some probability. Formally, we will assume that the distribution has the following form. The elements could represent, for example, baskets of shopping items or a set of pixels of an image. Performing inference in such general models is very hard, so we will make the assumption that the functions f and g are submodular. This will enable us to come up with scalable algorithms that can both yield an approximation to the constant c, also known as the partition function, and the marginal probabilities of individual items. We would like to point out that this decomposition is general in the sense that any distributions over sets can be written in the form above. There are many potential applications for these models, for example, in computer vision, summarization, sensor selection, and so forth. Let us look at the application in recommender systems in more detail. In this application, we want to suggest items to users in an online shop. To make good proposals, we need to model the utility of different shopping baskets. Let's assume that in our online shop we sell smartphones and smartphone accessories. In this setting, the submodular term of our model f can capture the notion of substitutional products. That is, when different items share the same characteristics. In our example, every smartphone is a substitute for every other smartphone, so that when the user has already selected a smartphone in her basket, the model will put a lower probability on all other items that have similar properties. The negative submodular term, that is a supermodular term in our model, minus g, can capture the notion of complementary products. For example, after a user has selected a smartphone, the probabilities of all suitable accessories, for example headphones, will be increased. In our paper, we present algorithms for performing variational inference in mixed probabilistic submodular models. These algorithms build upon the idea of carefully approximating certain differential structures associated with the submodular functions used for defining our model, enabling trackable approximate inference methods. We demonstrate the effectiveness of the proposed methods on a real-world product recommendation task, achieving significant performance improvements compared to several baselines. If this sounds interesting, please visit our poster at NIPS 2016. Our poster presentation is on Tuesday from 6 p.m. to 9:30 p.m. Our poster number is 7T. We hope to see you there.